In this episode, we look at a newer and very practical part of the modern attack surface: large language models, LLMs, misconfigured resources, public repositories, leaked secrets, and public object storage mistakes. These topics belong together because they all involve exposure. Something that should stay controlled becomes reachable, readable, searchable, or usable by the wrong person. An LLM connected to sensitive data can reveal information if access and prompts are not governed carefully. A cloud resource can expose data if permissions are too broad. A public code repository can leak passwords, tokens, and internal logic. Public object storage can accidentally turn private files into internet-accessible files. None of these risks require an attacker to break down a wall in the dramatic sense. Sometimes the dangerous path is created when a useful tool, storage location, or workflow is connected too openly and nobody notices soon enough. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. LLMs are systems that can process and generate language, answer questions, summarize text, draft content, classify information, and assist with many business tasks. They can be extremely useful because they help people work with large amounts of information more quickly. The security concern appears when the model is connected to sensitive data, internal tools, customer records, support systems, software repositories, financial information, or business workflows without enough control. You should not think of an LLM only as a chat window. In many environments, it may become part of a workflow that retrieves documents, drafts responses, searches internal knowledge, assists developers, analyzes tickets, or triggers actions through connected systems. The more it can see and the more it can do, the more carefully it must be governed. A tool that only answers general questions has one level of risk. A tool connected to private data and business actions has a much larger attack surface. One risk with LLM systems is sensitive data exposure. A user may paste private customer information, legal text, credentials, internal strategy, source code, health records, financial data, or incident details into a model without understanding where that information goes or how it may be stored. Another risk appears when the model is allowed to search internal documents and return answers to people who should not see all of those documents. The model may not be trying to break rules, but it can surface information based on the access design around it. If the underlying permissions are too broad, the model may become a very fast way to discover sensitive content. This is why access control matters before the model is connected to data. The model should not become a shortcut around existing permissions. If a person could not open a document normally, the model should not reveal its contents through a summary. Prompt injection is another LLM risk you should understand at a high level. A prompt is the instruction or request given to the model. Prompt injection happens when an attacker tries to manipulate the model's behavior through crafted text, especially when the model is reading outside content such as emails, web pages, documents, tickets, or messages. The attacker may place instructions inside that content, hoping the model will follow them instead of the user's real intent or the organization's rules. For example, a document could contain hidden or misleading instructions that try to make the model reveal internal data, ignore safety rules, or take an unintended action through a connected workflow. This is different from a traditional software exploit, but the security idea is familiar. The attacker is sending input that changes behavior in an unsafe way. LLM systems need boundaries, permission checks, and careful design because language itself can become part of the attack path. LLM risk becomes more serious when the model can take action, not just produce text. A model that summarizes a public article has limited reach. A model that can search internal files, create support tickets, send messages, update records, query business systems, or call an application programming interface (API) can affect real workflows. If access is too broad or approval steps are weak, a user or attacker may cause the model to do something unintended. This does not mean organizations should avoid automation completely. It means they should treat LLM-connected workflows like any other powerful system. The system should have limited permissions, clear human approval for sensitive actions, logging, monitoring, and separation between reading information and changing information. A model should not receive administrator-level access just because it is convenient. Like any account or tool, it should only have the access needed for its intended purpose. Misconfigurations are one of the most common causes of exposure in cloud and modern application environments. A misconfiguration means the technology is set up in an unsafe or unintended way. The service may be secure when configured correctly, but the chosen settings create risk. Examples include storage made public by mistake, overly broad identity permissions, open management interfaces, weak network rules, disabled logging, missing encryption settings, insecure defaults, or test systems exposed to the internet. Misconfigurations often happen because systems are complex and fast-moving. A team may create a resource quickly for a project, copy settings from an old example, approve broad permissions to make something work, and never return to tighten it later. Attackers look for these mistakes because they can be easy to find and easy to use. A misconfigured resource may give them access without needing a sophisticated exploit. Cloud misconfigurations can be especially risky because cloud resources can be created quickly and exposed globally. A developer may create a database, storage container, virtual server, or serverless function in minutes. That speed helps business, but it also means mistakes can happen quickly. A resource may be placed on the public internet when it should be private. An identity role may allow access to all storage when it only needs one folder. A test environment may contain real data because copying production data was convenient. Logging may be disabled, so no one can easily tell who accessed the resource. The cloud does not remove security responsibility. It changes where responsibility lives. The provider secures the platform, but the customer usually controls many settings around identity, permissions, data, network exposure, and monitoring. Misunderstanding that shared responsibility can turn a simple setting into a serious breach. Public repositories create another kind of exposure. A repository stores code and often stores more than code. It may contain configuration files, documentation, comments, scripts, dependency lists, test data, deployment notes, and sometimes secrets that should never have been placed there. A public repository is visible to anyone, including attackers and automated scanning tools. Even private repositories can create risk if too many users or connected applications have access. The danger is that code reveals how systems work. It may show internal service names, authentication flows, error messages, database structures, cloud resource names, or assumptions developers made. That information can help attackers plan more targeted attacks. A repository may not contain customer data and still be valuable to an attacker because it explains the environment. Public code should be reviewed carefully before it is shared, especially when it was originally written for internal use. Leaked secrets in repositories are a serious problem because attackers constantly search for them. A secret might be a password, token, private key, cloud access key, database connection string, webhook address, or API key. These values can appear in source code, configuration files, examples, test scripts, build logs, or old commits. The history of a repository matters because deleting a secret from the current version may not remove it from earlier versions. Once a secret has been exposed, the safer assumption is that it may have been copied. The response usually needs more than deleting the line. The secret should be revoked or rotated, access logs should be reviewed, and related permissions should be checked. A leaked secret can give attackers valid access, which may look less suspicious than a forced break-in. If the value still works, the attacker may simply use it. Public object storage mistakes are another common and damaging exposure. Object storage is a cloud storage model used for files such as documents, images, backups, logs, exports, media, and application data. The files are stored as objects inside containers that may be called buckets or similar names depending on the service. Object storage is useful because it can scale easily and support many business needs. The danger appears when private objects are made public, when permissions are too broad, when links are shared carelessly, or when sensitive files are placed in a location meant for public content. A public object storage mistake can expose large amounts of data quickly. The organization may not notice because the files are not on a traditional server in a familiar data center. They may simply be sitting in a cloud storage location that anyone with the right address can reach. The impact of public object storage exposure depends on what is stored there. If the objects are public website images, exposure may be intended. If the objects are backups, customer records, scanned documents, logs, invoices, source files, or exports from business systems, the damage can be serious. Logs may contain usernames, internet addresses, session details, or internal system information. Backups may contain full copies of databases. Exports may contain customer or employee data. Documents may contain contracts, legal files, or business plans. Attackers may search for public storage because it can produce valuable data without interacting with the main application. Public exposure also creates uncertainty. The organization may need to determine how long the data was exposed, who accessed it, what legal duties apply, and whether affected people must be notified. A single permission mistake can become a business, legal, and trust problem. These exposure risks often connect. A public repository may contain a cloud key. That key may allow access to object storage. The object storage may contain documents that an LLM-connected workflow later indexes. A misconfigured identity role may allow a model or application to read more data than intended. A test system may contain production data and be exposed through a public network setting. A developer may paste sensitive code or credentials into an LLM tool while trying to troubleshoot a problem. Each individual mistake may seem understandable in isolation, but together they can create a chain. Attackers think in chains because one exposed item often leads to another. Defenders need to think the same way. When one secret leaks, ask what it can access. When storage is public, ask what data it contains. When a model is connected to data, ask what permissions it inherits. Reducing these risks starts with knowing what is public, what is sensitive, and what is connected. Public exposure should be intentional, documented, and reviewed. Cloud permissions should follow least privilege, meaning each user, service, application, or model receives only the access it needs. Repositories should be scanned for secrets before and after code is shared. Secrets should be stored in protected systems rather than written into code. Object storage should have clear ownership, private defaults where appropriate, access reviews, logging, and alerts for unusual changes. LLM-connected systems should have data boundaries, permission checks, approved use cases, and human review for sensitive actions. The purpose of these controls is not to slow everything down for no reason. The purpose is to make sure useful tools do not accidentally become uncontrolled disclosure paths. There are several misunderstandings worth avoiding. One is assuming that cloud services are automatically secure because they are provided by a major company. The platform may be strong, while the customer's settings are still unsafe. Another is assuming that public code is harmless because it does not contain obvious data. Code can reveal architecture, logic, and secrets. Another is assuming that an LLM cannot create security risk because it only produces text. If it can access private data, summarize restricted documents, or trigger business actions, it can affect security. Another is assuming that a secret hidden in an old file or old commit will not be found. Attackers use automation to search constantly. Security improves when you assume exposed information may be discovered and used. That mindset leads to faster rotation, better monitoring, and more careful publishing decisions. As you continue with Security Plus version 8 and SY0801, remember that LLMs, misconfigurations, public repositories, leaked secrets, and public object storage all show how exposure has changed. The attack surface is no longer limited to a server with an open port. It includes cloud permissions, connected workflows, code history, storage links, model access, tokens, and data that moves between services. A powerful tool can become risky when it can see too much or do too much. A storage location can become dangerous when private data is made public. A repository can become a map for attackers when secrets and internal details are exposed. The practical habit is to ask what is reachable, what is readable, what is connected, what is trusted, and what would happen if the wrong person found it. Good security keeps useful systems useful while making accidental exposure much harder.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.